North Road made this.
Hello, I'm David Okeode, Principal Instructor at Kavis Cloud, 4 times Microsoft MVP and author of multiple books on cloud security. I would like to speak with you about our courses at Kavis Cloud. First, we are cloud security focused. We maintain an unbiased stance towards vendors, and we cut through all the typical marketing jargon in many trainings out there. We help you to understand things as they really are. The second thing that's unique about our courses is that we are multi-cloud focused. Our multi-cloud security courses covers the top 3 public cloud platforms out there: AWS, Azure, and GCP. Our instructors are not just trainers, they are seasoned professionals with real-world experience. The third reason is that our training modules are designed to provide practical hands-on experience. Our courses are packed full of hands-on labs that you find engaging and interesting. And finally, our prices are the best out there. I encourage you to check out our upcoming courses on our website and also testimonials from our students. See you soon at www.kaviscloud.com. Hello everyone. Hello and welcome to this edition of the Azure Security Studies meetup. So before we get started, if you're yet to register, if you're yet to join the meetup group, I'll put the link in the chat window. Please do ensure that you go to the meetup group and make sure that you join. So that way you would be notified of upcoming events. So usually we try to have this specific study event every week. Or if you're yet to register, just make sure that you register, and that's where you get notified. I've put the link in the chat window. So I mentioned last week, I said this week we're going to try to talk a little bit about sessions, and we're just going to cover sessions in a little bit more details. So overall, I mentioned that the goal of this study series is to cover what I consider to be the 4 key areas of cloud security, which is you're referring to identity, infrastructure and network, application, and then data. So we're going to be covering like those 4 areas of security in the Azure cloud specifically. So last time we were talking about identity protection. We're going to pick things up from there. We're going to look at tokens in particular. Tokens. So as we go through this, if you have any questions, make sure to put your question in the chat window. And if there's any thoughts, any comments that you want to share, make sure that you share that also. So that'll be much appreciated. So let's get started anyways. So what I was talking about, I think on the first day of this series, maybe about 3 weeks ago or so, I talked about the different authentication options. So we have more legacy authentication option, which we have with on-prem Active Directory. So we have, oopsie, my pen is not working yet. Let's try that again. So anyways, we have, I think PowerPoint froze. Okay, let's try to restart PowerPoint. Let's see if I can restart PowerPoint. Okay, anyways, while PowerPoint is restarting, talked about different authentication options. So we said on-prem Active Directory, we have legacy authentication protocols like Kerberos, NTLM. If you're using NTLM, it shouldn't be anymore. You should be off NTLM for a long time now. So, but anyways, you have Kerberos authentication protocol, but we mentioned that Entra ID doesn't use Kerberos authentication protocol, at least not natively, not by default. It uses a different set of authentication protocols. So we have OpenID Connect for authentication and OAuth for authorization. It also supports other authentication protocols. So it supports SAML for federation. But one of the things that's consistent with all of these authentication protocols that Entra ID supports is that they all operate using web transport. My PowerPoint is just giving a little bit of trouble here, so apologies. So anyways, all of them use, okay. Let's see if apologies, I'll just need to go queue the session for Task Manager very quickly. Let's queue PowerPoint and let's revive it. And task. Yeah, that's PowerPoint. Let's restart the PowerPoint now and see if that's all good now. Oh, let's try that again. PowerPoint. Okay. Let's go to downloads and let's open it up again. And hopefully it does not hang anymore. Let's see. Okay. And let's share the screen again. Okay, so let's give that a go again. So I said, whether you're talking about OpenID Connect, whether you're talking about OAuth, or you're talking about SAML, all of these authentication protocols or federation protocols, in the case of SAML, all of them operate over web transport. And the meaning of that is they can transport tokens using web protocols, using HTTP, HTTPS. And this significantly simplifies authentication and authorization. So the identity provider can be in a completely separate network. So the identity provider in this case, Entra ID. The application itself that a user needs to be authenticated to, that they need authorization to, could be in a completely separate network. But a user can go to access the application. The application redirects the user to Entra ID using web transport, using HTTP, HTTPS. Entra ID authenticates the user, delivers a token to the user's client using web transport, again, HTTP, HTTPS. The user's client gets the token and presents it to the application using web transport, HTTP, HTTPS. So again, everything now operates over like web transport, right? So that's one of the benefits of these modern authentication protocols like OpenID Connect, OAuth for authorization, and SAML for federation. They operate over web transport. So Microsoft's implementation of modern authentication protocols is Entra ID. And the basis behind Entra ID is the Microsoft Identity Platform. Microsoft Identity Platform has the following components to it. Number one, Microsoft Identity Platform, which is what Entra ID uses, is built using industry standard protocols, like the ones that I just mentioned to you now, right? With OpenID, with OAuth 2, with OpenID Connect, with SAML. So these are industry standard protocols. So they're not using anything proprietary here, right? And SAIM for in the case of like Sync. In terms of supported identities, there is support for enterprise identity. So if you work for an organization, the organization can create an identity for you in Entra ID. There is support for personal Microsoft account, MSAs. Microsoft account is not just limited to Outlook.com or Hotmail.com. It extends to any email address can be used to open a Microsoft account. And then it could be identities that exist in other Entra ID tenants. So all of this can be authenticated. From an endpoint and library perspective, again, these are industry satisfied endpoints. So Entra ID, which is Microsoft Identity Platform, uses OpenID Connect, which is what OIDC means, OpenID Connect Certified Endpoint. And what that means is that you can integrate with the Microsoft Identity Platform with Entra ID using any standard library out there that supports OpenID Connect. It does not have to be Microsoft Authentication Library. Now, Microsoft have their own authentication library, which is called MSOL. So they have that, but you don't have to use MSOL. But because again, industry standard. And then we have the Azure portal that we can use to manage the applications that need to authenticate and the APIs that users need access to. Now, let's go into the main topic that we want to cover today. Let's talk about Entra ID authentication flows. Entra ID as a platform supports multiple authentication flows. David, what does that mean? What that means is, depending on the type of application that is integrated with Entra ID, the flow of authentication will be different. So it's not just a single flow. There are different flows of authentication depending on which type of application that the user is authenticating to. For example, if a user is authenticating to a desktop application, you have a desktop application installed on your PC, right? Like your Outlook.com, not Outlook.com, your Outlook client, your Word client installed on your PC. Those are desktop applications, right? But those desktop applications, you can use the authorization code flow for authentication. Depending on the person that wrote the application, they could use the device code flow for authentication. They could use integrated Windows flow for authentication. So those are different authentication flows. If you're working with a single page application, so something that maybe built using a framework like JavaScript, React, Angular, and all those other type of frameworks, you can authenticate using implicit grant. But what I want to call out for you here is that Entra ID supports multiple authentication flows. But here's one of the things that I also want you to take away from this slide. Some authentication flows carries a higher risk than other authentication flows. Some authentication flows carries a higher risk than other authentication flows. For example, an authentication flow like the device code flow, which I'll show to you in a minute what that looks like, it's considered to be riskier. It carries a higher risk. Why does it carry a higher risk? It carries a higher risk because it allows authentication exchange across devices. What does that mean, David? It means that a user can authenticate to device A from device B. For example, David is authenticated to device A. And then someone hijacks that endpoint and they're able to transfer the authentication of David from device A to device B so that the token ends up on device B, not because a user has explicitly authenticated on that device, but because a user transferred the authentication or via using one of these other flows from one device to another device. So that's why they carry a higher risk, because these types of flows, they allow authentication transfer across devices. So this is one of the reasons why when you're working with conditional access, and let's go over to entra.microsoft.com very quickly. Let's go to duplicate that. Oh, let's do that again. Entra.microsoft.com. If I do entra.microsoft.com, and if I go to protection on conditional access, one of the things that you're going to see are conditional access policies is a new option. If you go under condition, a new option to control certain authentication flows. And you can see that at the moment, there are two authentication flows that are present here. You have the device code flow and the authentication transfer flow. Both of these authentication flows allows users to transfer authentication from one device to another device, which are considered to be risky. So keep that in mind. So let's proceed and see what some of these flows looks like. So these flows, here's what they look like. So for example, we have the implicit grant flow, which is used in single page application. Here is what that flow looks like. Here is a user authenticating to a single page application that's written using a framework like JavaScript, using Angular, using React, using Vue. So the user goes to access the single page application. Single page application collects the user's credentials and signs the user into the Microsoft Identity Platform, which is Entra ID. And when that is done, an ID token is returned. We'll talk about these tokens very soon. An ID token is returned to the single page application. Now, using the ID token, the application can make a request to Entra ID to acquire an access token to go access another API on behalf of the user. So in this case, maybe the application needs to read information in the Microsoft Graph about the user. The application makes a call to Microsoft Identity Platform. Microsoft Identity Platform returns an access token to the application. The application uses the access token to make a call to Microsoft Graph on behalf of the user and gets the response back, and then can present that. So maybe the application has read information about the user's name, the user's calendar information from Outlook, and the application is able to display that to the user. So for example, this information like the user's name, maybe that the application read that from Microsoft Graph, information about the user's calendar meeting, the application read that again from Microsoft Graph and then displayed that to the user. So that's an example of an implicit grant flow, which is mainly used for single page applications. But there are other authentication flows. We're not going to go through all of them because then it's going to get boring. I'm just going to show you like about two more. Here is another one. This is called the interactive authentication flow. So this one is mainly used where you have a server-side web application. Right? You have an application that's running in the back end. So maybe that's using ASP.NET Core in this case. Now, you have a user trying to use a web browser to access that web application. So this is the same application flow that happens for something like the Azure portal. So let's say this is the Azure portal. So the user brings up their web client and they go to access the application. And then what the application does is the application redirects the user to Entra ID. So now the user has been redirected to Entra ID, which is login.microsoftonline.com. So it says go authenticate to Microsoft Identity Platform. Actually, let me show that to you very quickly. Let me bring up Firefox on my system and let's see that in action. So I'll bring up Firefox. And if I go to the Azure portal, you see what's going to happen if I go to portal.azure.com. And if I press enter, you notice that I'll be automatically redirected to login.microsoftonline.com. That's what happened in this case. So the application redirects the client to login.microsoftonline.com, which prompts the user for credentials, which is what has happened to me in this case. I'm being prompted to enter my credential. And then the user enters their credential, which is submitted to Entra ID. Entra ID returns an access token to the web browser plus a redirect URL, which the redirect URL points to the authorization endpoint of the web application. The client presents the access token to the endpoint, and then the user is authenticated, and then the client can also use the access token to, for example, access Microsoft Graph on behalf of the user. So those are examples of like the different flows. I'll just show you one more flow and then we'll stop. Another flow is, this one is popular for those that have used things like, oh, what happened there? Let's go forward. This one is popular for people that have used not authorization code flow. Let's just go to another one. Okay, let's just go forward. Okay, yeah, this one, the device code flow. The device code flow, which is on the list of risky flows. If you remember what I brought up just now, when you're using conditional access, you can control that now. So it's on the list here. So you have the device code flow. So what is the device code flow? How does that work? So the device code flow is, this is the flow. So in this case, a user wants to authenticate to an application that does not have a way for the user to type anything into. So think about a user needs to authenticate to a smart TV, like an IoT device. Or maybe a user is authenticating to, let's see, a Linux system that doesn't have any UI installed, right? So a user is authenticating to a Linux system that doesn't have any UI installed. It's going to be using this device code flow. For example, if I go to the Cloud Shell and I try to re-authenticate myself manually in Cloud Shell, this is the flow that it's going to use. So let's go to have a quick look at what that looks like, and then we'll proceed to talk about rest of tokens. So let's go back to this. So if I go here and if I do AZ login, and in this case, this is using a device code flow because it says go to this URL, devicelogin.com, put in this code, authenticate, and then once you do that, the authentication is automatically transferred to this session. So that's a device code flow. So in this case, user wants to access an IoT application, a smart TV. Smart TV or the IoT application makes a call to Entra ID and obtains a device code, which is the code that you see that I have here. I have a code there. So the application obtains a device code and presents that device code to the user through a display. Go to devicelogin.microsoft.com, authenticate. User takes the device code and then goes to another device, authenticates to in the other device, puts in the device code. Once they've done that, that authentication is confirmed and an access token will automatically be delivered to the session, which is what happens here. So if I go to that URL and I put in this code, once I put in the code and authenticate, the token will automatically be delivered to this. And there you go. It's automatically signed me in. And there you go. So I'm signed in now. So anyways, let's clear the screen. So hopefully that makes sense to you. So those are some of like the common flows. Now, one of the things to keep in mind when we're talking about authentication flows here is that there are different tokens that are involved. There are different tokens that are involved in this case. So you have different types of tokens. You have ID tokens, which is a token that's used by OpenID Connect for authentication only, just usually just for authentication only. So it's not used for authorization. You have access token, you have refresh token, and you have authorization code. The two that I'm going to be focusing on are access token and refresh token. So, and you can see the difference and the different authentication flows and whether they use access token and refresh token or not. In many cases, you see that most of them use at least you need an access token to be able to access resources, and we'll talk about the use case of refresh token. But let's talk about some of these tokens very quickly. You have the ID token, access token, refresh token, authorization code. ID token, I'm not going to spend a lot of time on, but this is something, a token that's used mainly for authentication. It's not used for authorization. All an ID token contains is it contains information about the user. It does not really contain any additional information beyond just information that shows that a user has been successfully authenticated. And this is what an ID token looks like, for example. So you can see that there is an header part, there is the payload type part, and there is a signature part. So the header describes the type of token that it is. It's a JSON web token, and the type of algorithm that's used. The signature is what can be used to validate the integrity of this token, right? By whoever needs to do the validation, by whichever application needs to do the validation. So it includes that signature. And then in the payload, you can see that it contains only basic information. So basic information like the user that's authenticated, for example. So the user identity, which user is authenticated in this case, you have the user name there. You have the time that the token was issued. You have the preferred username of the user. You have the object ID of the user, and you have the tenant ID that the user authenticated to. So just basic information about the user. That's all the ID token contains. But what about the other tokens? Apart from this one, let's talk about them very quickly. The access token is what is typically used for authorization. In other words, you want to access a resource. You want to access an API. If I go to portal.azure.com and I sign into portal.azure.com, the access token is what allows me to see all the different resource information that I'm seeing. It's the one that grants me access to the different APIs that's displaying, that's returning all the data that I can view in the browser. So in this case, a user is using any client. Client initiates the authorization flow. The user goes to sign in. Conditional access policy kicks in. The user passes through conditional access policy. Entra ID validates the user, and then returns two tokens. It returns an access token and a refresh token. The access token can be used to access a resource. So that's what the access token is about. It's about accessing a resource. Refresh token, on the other hand, refresh tokens are used for re-authentication. So because what happens is by default, access tokens expire within 24 hours. So to prevent a situation where the user have to re-authenticate every 24 hours, the user can use the refresh token to re-authenticate without having to go through a sign-in process. Without refresh token, then you have to sign in every 24 hours again and go through the process again. But in this case, once the access token has expired, the refresh token is still there. The refresh token by default has a lifetime of 90 days. So once that has expired, the application, without prompting the user to re-authenticate, uses the refresh token to make a call to Entra ID and says to Entra ID, can I get a new refresh token and a new access token? So Entra ID returns a new access token and a new refresh token to the application. The application then uses the access token to make a call to the resource to carry on accessing the resource without having to get the user to re-authenticate themselves again. So that is what that flow looks like. Let's move on very quickly. By the way, while we're doing this, let me just go ahead and show you a quick demo of these tokens very quickly. So right now I'm on the Cloud Shell. So let's go see a quick demo. Hello, Random Voices. How are you doing? Thanks very much for joining. So let's go see a quick demonstration of access tokens. So what I do is, I think I have an application registered. Let me just check Entra ID. I think I have an application registered already, which is if I go, let me magnify this a little bit. Okay, let's go to on the app registrations. And in my app registration, I think I've got Token Workshop Hub. Okay, yep, I do have an application registered here. So I'm just going to use the same application, the Token Workshop Hub. So the main information that I'll need is I'm going to be using, let me bring up a notepad so I can show you what I'm doing here. Or what I'll do. Let's bring up notepad and I'll magnify that a bit. So here's what I'm going to do. I'm going to put my application secrets. Actually, you know what? I'll just re-register it again. It's just going to patch it for me. So actually, let me just do this. 02. Let's create a new one. So I'm going to register a new application in my Entra ID. It's going to be called Token Workshop App 02. And then I'm going to obtain the ID of that app registration. I'm going to obtain its client secrets. I'm going to obtain its object ID, and I'm going to obtain my tenant ID. So all of this I'm going to do using Azure CLI. So let's copy that and let's paste this. So registers the application, gets my client ID of the application, gets the client secrets, then everything else is done. So let's try it and make sure everything is good. So if I clear the screen, and if I just echo for client ID, make sure, there we go. I've got my client ID. I'm sure I have my other variables that's specified here also. So what I'm going to do is I'm going to make a call to Entra ID to get an access token for this client. And here's how I'll do that. I'll make a call using the call command option. So that's just a command line. So it's like an HTTP, it's like a web client. So I'm going to make a call. This time I'm going to be using an authentication flow of client credentials. Is the authentication flow that I'm using in this case. So that's why that says client credentials. If you remember from the slide, that's one of the authentication flow that we have on the slide. Let's go ahead and discard this and let's bring it up again so you can see the flow. So one of the flow that we have on the slide is this flow right here called client credentials. And that flow is mainly used for a daemon application, an application that's running without a user present. So it's running in the background. So that's the flow that I'm using. So I'm using a client credential flow, and I'm going to make a call to my tenant ID, and I'm going to make a call to get an access token. So let's go ahead and let's run this. So paste that and run that, and there you go. It's returned an access token. In this case, you notice that it returned an access token to me, but it did not return a refresh token to me. That again, I'll go back to the diagram that I showed you earlier. If you noticed on that diagram, you notice that the client credential flow does not use refresh tokens. So because again, a user is not present, so it's an application making a call directly. So it doesn't need to have a refresh token. If a user is present, that can help to prevent the user re-authenticating themselves. So refresh token helps in that case. But in this case, there's no refresh token returned. All that is returned is the access token that the application can then use to go access the resource that it's authorized to access. So that's what I have here. So I have that all my access token here. So that's in the bearer section. You can see my access token, and that's my access token here. It usually starts with EYJO. So anyways, let's clear the screen. So what I'm going to do is I'm going to get the access token again, but this time around, I'm going to store it in a variable. So I'm going to get that. I'm going to do an echo my access token. Yeah, so I've got my access token in a variable. And then what I can then do is I can use my access token. I can use it. I can actually just decode it. So let me just decode the access token. So I've got the access token. If I want to decode it, you can either go to a website online called jwt.ms or jwt.io, jsonwebtoken.ms, or it's JW with a J. So if you paste your token here, it's going to decode it for you, and you can see the claims that's included in the token. But you have to be careful where you put your token into, because anyone that has access to that token can do anything that the user is authorized to do. So you have to be careful about how you put that token. But if I want to decode it from my command line, I can decode it using this. So it's base 64 encoded. I can just decode it. So that which is what I'll do. I'll pass my access token and I'll decode it. So let's go ahead and I'll run it. And that has decoded the access token. So you can see the audience. So this is the service that this access token can be used to access. It can be used to access graph.microsoft.com. It can be used, it's issued for this application. That's the app ID. That's the identity provider, which is Microsoft Identity Platform, Entra ID, that issued the token, and then other information over there. So you can see like other information that's put there. Actually, let me just go ahead and just echo my access token. And let me echo my access token. Let me copy it and let me go paste it here. So I can show you some additional information. So here, if I go over here, if I go to under claims, you can see the different claims that's added. What if you want to include additional claims whenever a token like this is issued? That's something that you can actually control in Entra ID. So if you have your app, you can actually go to control and add optional claim for different types of token. In this case, an access token. I can say include additional information in the token that you return. So in this case, I can include the IP address of the client, so that's going to be included in the access token that's going to be returned. So anyway, that's a small short example of the access token and the other stuff. But there is a little bit of problem, and this is where I'll be rounding up. There's a little bit of problem, ladies and gentlemen, and here is the problem. So let's go back to our slide. I mentioned this to you earlier. Said the access token by default expires every 1 hour. The refresh token by default expired every 90 days. The only exception to this is a single page application, right? If an access token is obtained for a single page application, that access token, if a refresh token is obtained for a single page application, that refresh token will have a lifetime of 24 hours. So here are the few issues, ladies and gentlemen. Number one issue is that the client that made the call to Entra ID is responsible for safeguarding these tokens, this access token and refresh token. It's the responsibility of the client that the token was issued to safeguard those tokens. Now, that can be an issue because different clients take security differently. For example, Azure CLI if you're using legacy versions of Azure CLI, it's going to store the access token and the refresh token in plain text on the system. So that way, if someone is able to get remote code execution on the system, they just need to copy the token over to another system and they can reuse that token and act as if they are the user. They don't need to do any authentication. They've bypassed conditional access at that point. Remember that conditional access happens before the token is issued. Once the token is issued, that's really it from a default perspective. There are other things to consider, but from a default perspective, that's really it. Now, Microsoft fixed that for Azure CLI so that Azure CLI now encrypts the tokens, but that is only, it only does that if you're using Azure CLI on Windows. If you're using Azure CLI on a Linux PC or a Mac PC, the access token and refresh token are still not encrypted at rest. They are stored in plain text, which means you need to be a bit careful of that. Let me show you some information about this. So because there's been some GitHub issues that's been raised for a very long time for Microsoft to try to fix those issues. So this is the one for Linux. Encrypt token, enable token encryption when running Linux. So because the access tokens are in plain text when you're using Azure CLI on Linux. And the same thing for Mac OS. If you're using Mac OS and you're using Azure CLI, the tokens that are issued to your session are in plain text. So you can see for Mac OS, the same issue exists, and that's yet to be fixed. So what that means is if somebody can get access to a CLI system that has this Linux, if I do a list.azure, this is the location where you find the access token and the refresh token in plain text. And if somebody can get a hold of that file, they can essentially reuse the token to make a call on behalf of the user. So things are a little bit sensitive there. The other thing that also can be a little bit sensitive, or another question that people ask is it possible, because here's the issue with the refresh token. If someone, let's go back to the slides. If someone gets access to the refresh token, let's go back. So refresh token is used, it can be used to renew like access tokens, right? Talked about that. So imagine if someone that's malicious gets access to the refresh token. So here is a malicious user, get access to this refresh token. They can simply use that to obtain new access tokens anytime they need it. They just use that refresh token. Remember, it has a lifetime of 90 days. They use that refresh token to make a call to Entra ID. Entra ID issues a new access token to them. When that new access token is about to expire after 1 hour, essentially they just mint their own tokens, right? So you have to think about how to really protect like that refresh token. One of the things that Microsoft has started adding is a way to limit and enforce re-authentication. For example, in conditional access policies, apart from the option to control authentication flows, one of the other options that Microsoft recently added, if you go under the session option, is this option here to sign in frequency. So you can use this option to reduce the sign in frequency so that it's not going to be the lifetime of the refresh token. So if I reduce that to, let's say, 10 days, so that means any user that's been authenticated via this conditional access policy, they're going to be forced to re-authenticate every 10 days. So that way we can cut that short a little bit, right? So that's another consideration that you may have with regards to the refresh token and securing those. So as I mentioned here, refresh tokens are an attractive target for attackers. They represent the overall grants that the resource owner is delegated to a particular client. And if exfiltrated, they can be used to mint access tokens. So they can use refresh tokens to mint access tokens and then use them to access resource servers. So one of the things, which is where I'll end today, one of the things that we want to do is we want to make sure that flows like the device code flow, or flows like the authentication transfer flows, are only used in scenarios where they are necessary. What sort of scenario is that? Okay, in your office, you have a, a meeting room device in your meeting room. Meeting room device runs Android, and it needs to authenticate to Outlook online, right? So this will probably use a device code flow for authentication. But if a device code flow is used from a Windows device, you probably want to block that if there is no legitimate use for it in your environment. If there is, fine. Maybe you can limit the scope of use. But if not, you want to limit that to prevent, again, this token hijack type scenarios where people are stealing access tokens and refresh token and replaying them. So in this case, what I can do is I can say I can configure a policy that will apply to device code flow and authentication transfer flow. And then I can lock them down and say, here is the condition, look for this condition. And if the client, so let's go back to under condition, let's see on the device platform. If the device platform is Android that's using device code flow, then go ahead and grant access. And then you can create a follow-up policy that says, if the device client is anything but Android, so maybe if the device client is Windows, Mac, Linux, again, depending on, make sure that you check your sign-in logs before you do this. If it's any of these other ones, in maybe certain scenarios, maybe what you want to do is, if that's using device code flow, authentication transfer flow, what you want to do is you want to block access. So that's where you can try to limit some of like these opportunities for token theft in your environment. Hopefully that makes sense, ladies and gentlemen. Hopefully you've gotten some additional information around the different token types supported by Entra ID, how they work, some of the things to consider in terms of security, and hopefully you have a better idea of why Microsoft has added this conditional access policy to control authentication flows in Entra ID. If you have any questions, I'll be happy to answer your questions. Otherwise, that'll be for it for this week. We're going to pick things up from here next week. So next week, we're going to go a bit further. We're going to look at some of the tools that can help us in terms of like overall auditing of our Entra ID environment, making sure that the security is tight. So we'll look at some of the tools that are available out there. Some of them are open source tools, so we'll look at those. And then from then on, we can begin to pivot into things like infrastructure and network security in Azure. Thanks very much for joining me today, and I'll see you next time. Have a lovely rest of the morning, afternoon, evening, everyone. Bye for now.